Okay, so my name is Josh Simons from VMware. I work in the office of CTO, and my focus at VMware is on high-performance computing. I'm leading the effort at VMware in that area. That's not actually what I'm going to talk about today. I was asked by the organizers, I think in the spirit of their master plan, to talk about some things that are going on in the enterprise, and then potentially things that potentially have some impact or potential opportunities for the RDMA community. So in particular, what I'm going to talk about is the software-defined data center, and then we'll talk a little bit about software-defined networking, which is a piece of that vision, and then share some very, very early thinking in the spirit of a workshop setting on how RDMA and SDN might potentially live together in a harmonious future. We'll see. At least I hope to stimulate some discussion on the topic. Okay, so I'm not going to assume that everyone understands a lot about virtualization, but by the same token, I'm going to assume that you know the basics, right? So all of you, I'm sure, are familiar with desktop virtualization, where you can run a virtual machine, which allows you to essentially run one operating system on top of another. So in server virtualization, it's a similar idea, except you typically are not running a full operating system underneath the virtual machine, but in our case, you're running a highly optimized hypervisor, or a VM kernel is what we call it, that is creating that virtual abstraction that the virtual machine is running on. So that VM kernel exists really for the sole purpose of running virtual machine workloads, and as I said, it's optimized pretty highly to deal with that. One of the points that I wanted to make, perhaps with my HPC hat on a little bit here, is that there's been a lot of evolution, I would say, in this space. When back in the late 1990s, it was still generally held to be the case that x86 instruction set architecture was not virtualizable given sort of standard techniques that were available at the time, despite the fact that virtualization had been used for many years in the mainframe world. So it actually was a group of researchers at Stanford that came up with a way of doing virtualization for x86. That group of researchers actually turned into what became VMware. So we have a long history in the space. And the point I want to make is that original technique that the researchers developed was a purely software-based technique that used a lot of emulation in order to achieve the virtualization. It was doing things like just-in-time code generation, for example, to deal with some of the anomalies within the instruction set architecture. And the performance suffered for that, frankly. Now, it was good enough that enterprise applications were able to run on it, but what's happened over the intervening decade or more is that with the help of hardware partners, we've greatly increased the performance of the virtualization layer. And that comes through hardware support for CPU virtualization, hardware support for memory virtualization, and hardware support for I/O virtualization as well. And it's an ongoing story as the hardware continues to add additional capabilities to support virtualization, and as the virtualization software improves itself, the performance changes pretty drastically as both of those waves kind of advance. So I'd say that old data typically is bad data when you're looking at performance in a virtualized environment. So a short plug here for those that are thinking about using virtualization for HPC. You should definitely look at newer data, not old data. Now, so this server virtualization forms the basis of a virtual platform, but for those not familiar with virtualization, let me sort of take you through kind of the journey that we see ourselves on. So starting on the left is the server virtualization that I'm talking about. That was really all about creating these virtual machine abstractions and allowing them to be hosted on physical hardware. And the name of the game there was to support certainly more than one virtual machine running on a single physical system for a variety of reasons that we don't need to go into. What has happened since then is that we've moved, the base virtualization capabilities have sort of matured and expanded beyond the individual box to actually deal with full data centers full of boxes. And in support of that, what we developed is a capability to have policy-based resource management, cluster-based resource management. So you think about it from an HPC perspective, we're very familiar with the idea of load balancing of workload across a cluster. What you do in a virtualized environment is similar, except that we're able to actually move workload as it's running and shift it around amongst boxes in the data center as is needed to support different policy requirements that are set within the virtualization platform. So it's a lot more than just a virtual machine abstraction. There are issues around storage, there are issues around networking, issues around security. So that's kind of where things stand or stood, up to say 2010 or so. The next leap really is going beyond a single data center or beyond sort of small clusters of sort of modestly sized clusters that have this mobility that I just described, to actually supporting a hybrid cloud model where you really want mobility of those applications and workloads across a much wider range. You want to be able to do it across a full data center, and you also want to be able to do it, say, between a private cloud deployment and a public cloud deployment. So that's sort of the next leap that we're moving towards. And along the bottom there, you'll notice that I'm saying that the virtual machines, the machines were virtual in sort of the first generation there. But by saying physical storage, networking, and security, what I'm really saying is that, underneath the hood, of course, it's all physical, but the way that was reflected up into the virtualized environment is kind of less than optimal. And I think the way we normally tell that story goes something like this. So in the past, if you were an organization that was going to deploy a new service, you needed to go out and purchase a piece of equipment. You talk to your purchasing people, your IT folks. You're talking about, depending on your organization, 10 weeks, and put a number on it. But it's a long time to go out and get a new piece of equipment and bring it in, get it wired into your data center, get it spun up, and then get your service up on top of it. So the first wave of sort of innovation from the virtualization space was to create the virtual machine abstraction. And so then we say, fine, all right, so now you push a button and poof, we give you a virtual machine. It's all done in software. Well, that's great. And that sounds like kind of the end of the story, but it's actually not, right? Because these systems don't, your machine does not exist in isolation in a data center, right? You need to provision storage, you need to set up your VLANs in order to allow connectivity from the VM to other things in the data center. You need a firewall, you might care about intrusion detection, you might want to set up high availability. So there are a lot of things that get, a lot of services that get wrapped around the sort of base virtual machine abstraction that need to be set up. And now we're talking about maybe 5 days and 2 minutes and more money, right? So it's, there's operational complexity and there's time involved in dealing with this. And this is a real problem if we're going to move to sort of the next level, right? So what we want to do is take this sort of 5 days and 2 minutes, and turn it into something that looks more like this, which is that we create essentially a virtual data center abstraction. And that data center abstraction is underpinned by a set of software, all software services that allow us to provision networking, provision storage, provision security, and compute and memory, et cetera, all the resources that you need to actually stand up the service that you're intent on standing up, but do that totally from a software-based perspective and do it at scale. That's the critical piece here, is doing it at scale. So we want to turn that into sort of a 3-minute kind of thing. And that's absolutely necessary if we're going to move into the cloud. And that, sort of simply put, is what the software-defined data center is about, right? So you've got the cloud. We've talked yesterday in some detail about what a cloud is. I think we all know that. And really, the way to think about software-defined data center, from our perspective, it is the architecture that lets us deliver the cloud. So it's how we would build it, as a provider of software, and as a provider of software to customers that are building clouds. This is the underpinning that you would use to do this. And the important piece of this, I guess, is sort of summarized this way. Our mantra in the space around software-defined data center is to abstract, pool, and automate. You'll hear that a lot from us. So the idea is that you abstract all of the networking, security, as I said, the compute, memory, et cetera, storage as well. you decouple that from the physical infrastructure, make these things that are provisionable totally at the software level without having to go and do a lot of kind of low-level detailed work to set them up. You pull these across a wide range of physical resources, and we'll come back and talk about this in a little while, but the idea of thinking of this as a pool is really important. We want to see this as essentially an undifferentiated pool of compute and storage and networking and et cetera, where any workload could be placed anywhere in that data center. If you think about building high-scale multi-tenant cloud environments, that kind of flexibility is going to be absolutely key to making efficient use of those hardware resources by our customers. And then automation is clearly important as well, right? We're talking about extremely high-scale, potentially very high-scale cloud environments. And if it's not automated, it's just not going to work correctly. Sorry for those hokey animations. I did take these from some of our vision slides. So this, software-defined networking, this is a simple analogy, but I like it, right? So, in the telephony space, the idea of moving from kind of landlines where you're sort of tied to your physical location, your address and your physical location are intimately intertwined, moving in the telephony space towards wireless, where you have an address, but that's completely untethered to, with respect to your physical location, is very similar to what we're trying to do with software-defined networking, right? So there is an uncomfortable amount of tying to physical that still occurs in the current approach. And what we want to do is move to an environment where the VMs are kind of free to move around in the cloud environment. As I said earlier, VXLAN, is the technology that we're pursuing there with, a fairly good group of partners as well. But this is the idea of encapsulation, right? So the ability to encapsulate Ethernet in IP gives us the ability to have the kind of decoupling that we need, and the ability also to move these endpoints around within the data center. The other piece that I would call out as sort of defining component of software-defined networking is the centralization of control, right? The idea that you have a controller that is making decisions about how to program your forwarding plane, basically, to set up the SDN fabric in a way that's required for the workload that you're supporting, and also so that it can change it dynamically to support, again, this sort of multi-tenant cloud environment where what's actually happening in the data center changes, from time to time or on an ongoing basis. Okay, so with that, let me now talk about RDMA, and then try to bring this back together again and talk a little bit about SDN and RDMA. So to be, just again, sort of background, to be really totally clear about this from a virtualization perspective, we care about low latency in two different ways in a virtualized environment. There's the virtual infrastructure itself, so the software that we provide as a virtualization vendor, and then there's the guest operating system, which is the operating system that's running in the virtual machine that's running your application. So both of these are important places for us to look at using RDMA to advantage, and let me just briefly talk about what those look like. So virtual infrastructure RDMA, so in other words, this is RDMA communication between the hypervisors. So think about this as sort of kernel to kernel between boxes. It's a physical environment, right? Because we're running these hypervisors are the kernel that's running on the real hardware. So this RDMA capability would allow us to accelerate some of the capabilities that we offer in the platform that are distributed capabilities, and I've listed three of them here. So vMotion, or which is more generically called live migration, is the ability to dynamically move workloads that are sitting in a virtual machine on one box to another box. We've done some experiments, and Bhavesh last year reported on those results, and he and Aaron will give an update in a few minutes about where that all stands. But we've done performance studies that show there's a huge advantage to using RDMA in that capability. Also, interstate VM state mirroring. So we have a fault tolerance product that mirrors state between two running VMs for fault tolerance. Low latency, high bandwidth are extremely important there. We're also developing what I would call a virtually shared fabric, basically, that's based on direct attached storage that looks like looks like a shared fabric to a set of VMs, but it's actually instantiated as a set of interconnected DAS devices. And again, high bandwidth, low latency is quite important there. And CPU offload, I should just throw in here as well. Anything we can do to offload the amount of resources that we use, compute resources we use sending data across pipes, is something that we can use immediately to advantage. You know, in HPC, we talk a lot about overlapping communication and computation, and that being one of the reasons that we'd like to use CPU offload. In practice, that's not achieved a lot of times in HPC because the applications aren't written that way. But in a virtualized environment, we have many, many virtual machines running on an individual node. So any CPU resources that we can can reapportion towards running virtual machines can actually add significant value to our customers. So that capability is important as well. Okay, on the guest side, this is again RDMA access from within a virtual machine or the guest operating system for support of applications. And I think we've talked about this last year, and others have said this as well. So we're definitely seeing, you know, an increase in scale-out middleware and applications and becoming increasingly important in the enterprise. Cassandra, MongoDB, so DK Panda presented some Memcached results yesterday. That was interesting. Gemfire is an in-memory database that we build that would benefit from this, and then the distributed databases as well also benefit from RDMA. I think we all know that. Also, DK presented some information about big data yesterday. That's clearly an area that would benefit in the enterprise. It's a huge exploding area within enterprise computing at this point. And then increasingly HPC, which is what I focus on, but we won't talk more about that. Okay, so let's talk about SDN and RDMA. Now, I reiterate that this is very early thinking on our part, and it might be wrong. We'd love to have further discussions about this, but here's the way we've been thinking about this so far. So kind of teeing up the question. So on the one hand, SDN is all about decoupling the logical network from the physical hardware, right? And encapsulating Ethernet and IP, which is adding more layers to the software stack, right? So, and flexibility and agility are really kind of the, what we're looking at in terms of primary goals. On the RDMA, on the other hand, direct access to the physical hardware, getting as much software out of the way as you possibly can, going to fewer layers with performance as the primary goal. So the question is there any hope of combining these, or is this, never the twain shall meet sort of situation here? Oops, yes, okay. So, so let's consider these. Here's some glimmers of hope as I've labeled them here. So the first one is that, and these are sort of, they're not direct evidence that there's a way of combining the two, but I think from a philosophical perspective, they're interesting. So I think we'd note that while 50% of the data center workloads in the world, it's estimated, are running virtualized at this point, many customers do have a mixture of physical and virtual. So, and I would say that that's going to continue for a long time. I don't think everyone's going to go virtual for quite a long time, despite the fact that we're making pretty substantial headway in that space. So what that means to me is that as we think about this sort of highly virtualized environment with extra layers, et cetera, we still need to be thinking about how you get access to bare metal resources, even if it's only from a management perspective. Can we merge sort of physical environments and virtual environments at the management level so that you can handle all of those in kind of one operational way? And then the other important thing to call out, as I sort of alluded to earlier, is that the need for low latency and high bandwidth interconnect in the enterprise is a clear trend. We definitely see that happening. So what that means is that even if we don't know how to do it at this point, we really do believe that SDDC, the software-defined data center, and SDN must accommodate these realities in the future data center. So the question is how to do that. It's not whether it should be done or not. The question is how, from my perspective. Okay, so other things that I think give some some hope that we can figure this out. It's not. I note that SDN splits the control and data planes and uses a centralized controller to program the switch fabric, which is very familiar to the folks in the room here. SDN is exploring, I wouldn't say it's sort of breaking the abstraction, because we're still, the abstraction that we're offering upward to the virtual machines is still full mobility, endpoint mobility, and decoupling. But the SDN implementation itself, they're now looking at reaching down into the physical infrastructure and pulling more data out of there. So looking at things like metrics and doing topology sensing so that more optimized placement decisions can be done by the SDN layer in support of delivering better performance for virtualized applications. So that also sort of, to me, is thinking that's in the right direction of how you actually get to higher performance. And then the last one riffs off of what Harry was saying yesterday. This whole point he made yesterday about more east-west or peer-to-peer traffic appearing in the modern data center is definitely true. It's something that we're seeing. But what we'd want to note is, because we want to treat the entire data center as an undifferentiated pool of resources and have the ability to place any workload anywhere in that environment, that essentially creates a very large need for east-west data. And in fact, it was even pointed out to me by one of our SDN folks, is that even traffic that you would view as north-south traffic in a virtualized environment may well end up being laid out in an east-west direction. So what that's doing is driving, we believe, will drive data centers in the direction of interconnects that have higher bisection bandwidth and much lower, more uniform latency, which again, I think plays in the direction of where the RDMA community has been for a long time. Okay, so here's our little rocky thought experiment. If there are errors, help us out with this. But the question we were asking is, could Rocky be used as the basis of an SDN environment that also supports RDMA? So first off, Rocky seems to satisfy both of SDN's basic requirements, right? So we can get IP connectivity to all the hosts, which is needed for the SDN controller to actually communicate with them and control them. And we need IP for Ethernet encapsulation for the VXLAN approach. So those are both there. We need to support hypervisor-to-hypervisor traffic, as I mentioned earlier. So that is support for both IP and RDMA traffic. And as I mentioned, the RDMA primarily would be used to accelerate virtual platform services. That all seems okay. So we also, as I said, need the VM-to-VM traffic. So clearly the IP connectivity would be there for applications that don't need the RDMA. And then, as we presented last year, and again, as you'll hear in a few minutes, there are two approaches to making RDMA visible within the guest operating system. One is to do direct pass-through, which punches the card directly up into the VM so that it can access it directly. And the other is to use a paravirtualized approach, which we actually would prefer because it does give us endpoint mobility. It doesn't tie the RDMA endpoints to individual nodes in the data center. It allows them to move around like other applications and workloads can move around. So that all seems good as well. And it also seems like we can support simultaneously sharing of that interconnect for everything, for hypervisor to hypervisor, for VM to VM, for IP, and for RDMA, all simultaneously. That's going to be required to actually pull this off. One question I had that we haven't really thought through is the visibility of the RDMA traffic to the SDN framework. If we're sensing within the framework what's going on, are the data transfers that are happening over RDMA, are those sort of like dark matter that aren't seen by the framework, or would we do something to make that visible, or put some kind of QoS guarantees in place to sort of mediate between the SDN IP traffic and the direct RDMA traffic? That's something that would need to be thought about. But basically, it seems like Rocky could support what's necessary for SDN management and for the data paths, and also allowing hosts and VMs to take advantage of RDMA. For IP over IB, maybe it's the same answer. We're not sure. I was interested in the Mellanox presentation yesterday that showed the set of limitations that IP over IB has versus E over IB. So I think there's a question of whether or not IB satisfies the requirements or not. So that's something that we could talk about. So in summary, the software-defined data center, we see it as an absolutely critical component for delivering cloud especially scale-out cloud. SDN is the means that we will use to decouple the underlying hardware as delivering part of the SDDC vision. RDMA, clearly important in the enterprise. We definitely get that. And we'd value continued discussions in this area to figure out what the right approach would be. That's it. Thanks. Any questions? Yes.
Could you say some more about the sort of synergy between the subnet manager and the control plane?
Yeah, I'm not sure at this point that so the question was, can I say some more about the synergies between the SDN control plane and the subnet manager? I don't think I can at this point. I think we're just noting at a high level that, philosophically they're kind of similar, but the devil obviously is in the details here. Absolutely. Yeah. Yeah. Yes, more questions?
You mentioned SDN exploring or providing additional telemetry for understanding the topology of the network.
Yes.
While maintaining the abstraction. Can you elaborate or perhaps talk a little bit more about what that means?
Well, so the idea is that the SDN implementation itself would be able to look down into the fabric and understand what the topology is. And so when decisions are made about placement of resources in the data center, that information can be factored into where the placement occurs, but that doesn't reflect upward it doesn't break the abstraction that's offered upward to the virtual machines, for example.
So is the vision perhaps exposing that type of information to the application layer so people can make...
No. So the vision is that it's exposed to the SDN layer. The SDN layer uses that for making decisions. It still looks like a flat infrastructure to the VMs. And I should mention, although I can't fully explain this, unfortunately, that the SDN folks have told me that it is a little bit controversial in the SDN community to be thinking about exposing the topology in that way. And I'm not quite sure why. Yeah, I actually think that if we really do go to a flat network with high bisection bandwidth, then it's less important that you have that. Clearly, it's important under high load circumstances, but it becomes less important to do that, and that might be the reason why they're seeing it as controversial. There's another question up here.
No, I don't. I just had a quick question. There was some conversation that SDN kind of started out really fast and that it may not have all the promise and that it's kind of had some fits and starts. Can you comment on that?
Yeah, so I'm not by any stretch of the imagination an SDN expert or even a networking expert. But what I guess I would say from a VMware perspective at least is that, so we made an acquisition in the last year or so, the Nicira, which essentially forms the basis of the OpenStack networking fabric or approach. And as I sort of indicated in this deck, we view software-defined networking as a critical piece of delivering kind of on the future cloud vision. So, this is a technical forum, but I'll briefly say, VMware is, by far the leader at this point in the virtualization space. I think of the 50% of the workload that's virtualized on data centers at this point, about 80% of it is on VMware. And I think as a sort of market leader in the space, as we continue to push this direction, I think it will gain more legs. And there are a lot of vendors that are playing in the space. I can't really speak in detail to that, but there are a lot of vendors playing here.
Just to add to that.
Oh, hey.
Yeah, sorry, I was here to support you. In fact, it's far from that. It's the opposite. SDN is gaining a lot of traction in the industry right now. There was the Open Networking Summit, the second Open Networking Summit last week, which generated a lot of interest in the industry. And the telecommunications players are also looking at SDN in a very serious way. They have started a new initiative called Network Function Virtualization, where they're trying to use SDN principles to take the underlying network infrastructure, the core network, the wireless network infrastructure, and use SDN principles to virtualize those core networking functions.
Thank you very much, Josh.